Welcome to another math video. I am your teacher, Mr. Grant. Here's our learning target. I can use a rule to find equivalent fractions. Before we do that, I'm going to tell you very briefly about a book that I am currently reading right now. And if you get a chance today and want to tell me in a sentence or two about a book you're reading, feel free. I don't think we'll have time at math group, but maybe during snack break or tomorrow, or just sometime if you want to tell me about a book you're reading, I would love to hear it. The book I am reading right now is called Ringer, and it is about a boy who becomes friends with three other boys, but the three other boys aren't very nice, and they're actually bullies. And they love to pick on this one girl that is the main character's neighbor. The main character's name is Palmer, and they pick on this girl that lives across the street from him that is a year younger than him. She's in second grade, he's in third. And the reason it's called Ringer is it's a book about pigeons, and something happens to those pigeons, and I don't want to spoil it for you, but this is a very good book. It's a longer chapter book. It's realistic fiction, but it's about, anyway, so Palmer, this boy, doesn't really have friends, and he gets in friends with these boys that are bullies, and he starts acting the way they do, and he ends up not being friends with really the only person that was ever his friend, Susie. She would come to his birthday parties, nobody else would, and Palmer just desperately wants to fit in, and unfortunately becomes friends with the wrong crowd. And I haven't finished it yet, so we'll have to see how it ends. So anyway, our learning target again was I can use a rule to find equivalent fractions. So let's take a look at this right here. So we have some fractions. Now if you notice, for instance, on number 1, all of these fractions are different, 1/2, 3/6, 6/12, but they all look like they're the same. If you look at these pictures, even though they're split up differently, divided differently, looks like they are the same size. So my question for you is, what could be a rule that we could use to get from this fraction to this fraction, or from this fraction to this fraction? Because they are equivalent, but what could be a rule on how we got from this fraction to this? Take a look at these ones. Again, it's the same thing. It's a third of each circle, so these are all a third, but we have 1/3, 2/6, 4/12. What could be a rule? How can we get from 1/3 to here, from here to here? And for it to be a rule, it has to work all the time. So how do you think they got from here, from 1/3 to 2/6, from 2/6 to 4/12? If it's a rule that works, it'll work for getting from here to here and here to here. Or even right here, 2/3. How could you get from 2/3 to 4/6, from 4/6 to 8/12? Is it adding? Is it subtracting? Is it multiplying? Is it dividing? And if it's one of those, what number? So I will have these fractions up again in group, but I want you to think, using the rest of the time, what is the rule for how we got here, and be ready to share it. And remember, the rules for each of these fractions might be different, but how are we getting from there? It's not going to be adding for one and subtracting for the other. It would be adding whatever, subtracting whatever, multiplying whatever, dividing whatever for all of them. It's just we might be using different numbers. So see if you can come up with a rule when you come to group. Bring your math journal and a pencil.